Now, welcome to electrical machine lecture. Today we'll start a new topic, that is testing of DC motor. It is also called as a brake test, and second is the indirect load test or indirect test. So rather it is a uh, indirect test only. So it is indirect test. Uh, in the direct test, the motor is directly loaded, means actual load is applied over the motor with the help of brake and pulley arrangement. Uh, Whereas in the indirect method of testing, the load is not applied on the motor, whereas some of the calculations are carried out on the no load condition, like Swinburne test. It is also called as a no load test. Whereas the second method is the Hopkinson test. It is a back-to-back test or regenerative test. In this test, two identical machines are required, one acting as a generator and second acting as a motor. So very less amount of power uh, is taken from the mains. Therefore, it is called as a regenerative test. And third is the field test that is used only for the DC series motor. So first we will discuss the direct load test. In the direct load test, the motor is directly loaded. Therefore, the load on the motor is at actual, and therefore the result found from the direct load test is more accurate as compared to the other method. In case of the direct load test, the motor is loaded with the help of brake and pulley arrangement. Uh, this is shown in this diagram. Say this is the motor and this is the motor pulley. Let the radius of the motor pulley is R. Then the force acting over over the pulley is nothing but the spring tension or spring balance provided on the both side, which is going to measure the load in kg. So kg, it is the force in kg multiplied by the radius, so it become a torque. So by this way, it is possible to find out the torque, and from the torque, it is possible to find out the mechanical output of the motor. So here, this is the, it may be a both spring balance may be adjustable, or one can be put, one spring may be put as a fix and second spring is a variable. So this is the handle is provided over the this mechanical arrangement, loading arrangement, by which by adjusting this wheel, it is possible to load the motor, means apply the brake over the pulley of the motor. So this is the at actual figure. Here the spring balance, two spring balance are there, and one drum, pulley and drum is applied. This pulley is this such type of drum construction is used, or we can pour some water to avoid the overheating of the pulley because it is a friction between the belt and the pulley. So this is the DC motor. In case of direct load test, the motor may be a DC series motor, it may be a shunt motor, or it may be a compound motor. In AC machine, the machine may be in case of the three-phase induction motor, single-phase induction motor. So every type of motor can be tested by every type of motor can be tested by the direct load test. Only there is a drawback is that such test is applied only for the small capacity or some moderate capacity, because the load is not available, that much load is not available. This is going to discuss in the advantage and disadvantage of direct load test method. So first we will see how to apply the direct load test for the DC shunt motor. Here one can use the DC shunt motor or series motor or a compound motor. So this is the diagram of the DC shunt motor. This is the armature. This armature is mechanically coupled with the pulley arrangement as explained earlier, whose radius is R, and this is the spring balance S1 and S2, which is going to measured in kg. So it is going to measured in kg, whereas the R is the radius of this one. Now this is the field winding. We can put some of the resistance to adjust the field current to obtain the rated value. Here it is not shown, but we can use a series resistance in the field winding. This is the armature current. It is going to measure the total current drawn by motor, say let I, and the voltage V, voltage across motor is the V. It is in the voltmeter. It is measured by the voltmeter, DC voltmeter. Now here it is the starter. It is the starter terminal, because DC motor is always started with the starter. It having three terminal. L is connected to the main, and whereas F is connected to the field winding and A is connected to the armature. Now inside there is a starter, say all things are there, which is already explained in the starter. Now what is the procedure? First we will say it is the procedure. First run the motor at rated voltage at rated speed. Rated speed at no load condition. No load condition means the spring balance S1 and S2 is showing zero value. So it means that there is a no brake is applied over the pulley of motor. That's why the the motor is no load condition. Therefore, this is at the no load condition. Under no load condition, we will find the speed is a rated one. What is the rating? What is the rated speed? It is the speed which is shown over the uh, nameplate, and it is called as a rated speed. So in the nameplate, it is given as what is the output rating? That is the how much is the output power either in the kilowatt or it in the HP, what is the rated voltage, what is the rated speed, type of insulation, type of enclosure, all the things are given on the nameplate. So it is necessary to know what is the rated current and the rated speed. Therefore, uh, it is possible to load the motor. So how much load has to be applied in such a way that the motor draws the rated current. Therefore, the nameplate reading is very important. Now, second, now load the motor by applying or by loading loading the brake arrangement. In steps till the motor draws full load current. Okay, so once we run the motor at no load condition, we will find there is a rated voltage and a small current is going to flow. It will draw the small current at no load condition. But as soon as we load the motor by adjusting the spring balance by either one or both, we found the spring, as soon as we increase the load, means as soon as we load the spring, in such a case, there is a more friction over the belt and pulley and motor current draws increasing. This increase in current indicate that the motor is loading, actual loading is there. Now we have to ensure that the load on the motor or the motor current should not uh, cross the maximum or the its rated value, and it has to be known from, it has to be understand with the help of uh, nameplate of the motor. Now once we load the motor, we have to take the reading in each and every step after loading the motor till it's a full load current. So now what are the observation? The observation will be, say here, supply voltage. It is, say for example, 230 volt is the rated voltage or 220 volt is the rated voltage. No load current, no load speed is given as a 1500 rpm or whatever the reading is given. And under no load condition, the first load will be, say 0 0. Say let we will consider that the first reading, it is rated as 220 volt. Okay, and whereas the current is say 2.5 ampere at no load condition, whereas speed is, no load speed is 1500 rpm, whereas the spring balance, first and second spring balance is 0. Now in the second case, what happened? The rated voltage, the voltage applied is as it is if we are keeping the voltage constant. Then the current is increases by 3.8 ampere we are considering. Whereas the speed, there is a slight drop in speed 1490 rpm. So one spring balance is showing 0, whereas the say first spring is showing as 2 2 volt. It is showing as 2 kg, whereas it is at 0. So by this way, uh, we can measure, we can observe there are different reading till it's a full load current. Okay. Now, what is the procedure to calculate the efficiency of the motor or to find out the performance of motor with the help of direct load test? So for that purpose, we have to measure the diameter of pulley or the radius of pulley. So we will consider the pulley radius. Let we will consider, let R is the radius of pulley in meter. Now spring S1 and S2 are the spring balance in kg, and N is the speed of motor in rpm. It is the supply voltage. It is in volt, and I is the current drawn by motor in ampere. Okay, so we can find the total load S is equal to S1 minus S2. If the S2 is greater, then we can take S2 minus S1, but it is in the positive value. It is in kg. Now this is nothing but the force, or you can say that it is the force in kg. Therefore, shaft torque TSH is equal to force multiplied by radius of the pulley. So here the radius of pulley is given in R. So it is S1 minus S2 into R. So it is in kg meter. So the shaft torque, it is in kg meter. But for our calculation, we need shaft torque in Newton meter. So TSH is equal to 9.81 multiplied by S1 minus S2 or S2 minus S1 into the radius. So it is in Newton meter. So by multiplying the gravitational force 9.81, so it is in the this one. Okay. Now the power output is equal to, let it is a P out, which is equal to torque into angular velocity. So output torque, it is TSH multiplied by angular velocity. So it is twice pi n upon 60. It is in radian per second. So speed is given in the RPM. So divided by 60. So therefore, the power output is 9.81 into S1 minus S2 multiplied by the radius multiplied by twice pi n upon 60. So this is the output power. Whereas the power input, it is not necessary to remember this one. It is only from our basic idea or basic fundamental of the power, torque, and this one. Now power input is equal to supply voltage, that is voltage multiplied by current drawn. So it is PIN, power input, is equal to V into I. It is in watt. And this power also in watt. So once we know the power input and power output, we can calculate the efficiency. Efficiency is equal to power output divided by power input multiplied by 100. So it is in percentage. or we can calculate by P out upon P in into 100. So the efficiency of motor we can calculate at any load condition. Now, one more thing, we can calculate the speed regulation. Speed regulation is no load speed minus load speed divided by no load speed. It is no load speed multiplied by 100. So it is in percentage. So percentage regulation and percentage efficiency. Okay. So if you take the number of multiple reading and till its full load condition, we can obtain this is the calculated values. The power input is nothing but the P into I. It is the power input drawn by the motor. Load on the motor in kg, S is equal to S1 minus S2. It should be a positive value. So either it may be a S2 minus S1. It is a positive value. Speed at no load condition, the speed will be 1500 RPM, whereas by increasing the load, the speed decreases for the different type of motor. For the DC series motor, there is a large decrease in speed, whereas for the DC shunt and compound motor, the drop in speed will be smaller. Shaft torque, we can calculate 9.8 into S. S is the difference of this value multiplied by the resistance. It is in Newton meter. So similarly, we can find the power output TSH into angular velocity, efficiency, and speed regulation. So once we calculate all these things, it is possible to draw the performance characteristic of the DC shunt motor or DC series motor under the direct load test. So this is the some procedure which is used to find out the efficiency and speed regulation of machine motor by the help of direct load test. Now, what are the advantage and what are the drawback of this direct load test are? First, we will see the what are the advantage. This test requires no other machine, thereby reducing the cost of the energy. Cost and energy. The meaning is that it require only one machine, only the motor which is going to test it. Either it may be a DC series motor or shunt motor. So it requires only one motor which is under the test. So this test is simple. The calculations, the steps of calculations also very less. So this type of test is simple in calculation and very convenient for the DC shunt motor or any type of DC series motor, compound motor. So every type of motor can be tested with the help of direct load test. The efficiency can be determined under any actual load condition from no load to full load. So whatever the load which we are taking, it is at actual. So we are going to find out the test under load condition at actual value. Some more important points which is not written here. One point is that as we are loading the motor directly, motor is actually loaded. So we can observe the vibration, the sounds, as well as the temperature rise of the motor. So these are the advantage of the direct load test. In addition to these advantages which is mentioned over here, the additional advantage is that we can observe the mechanical vibrations, commutations, sparking over the brushes, and temperature rise of the machine. So these are the advantage of test. Now disadvantage. the test is performed on small motor only. This is the very first drawback, is that such motors are the motor is tested should be a small capacity, because if the capacity of motor is large, the power requirement of will be more large. At the same time, the load is not available. Say for example, up to 5 hp, 10 hp, it is possible, because the 10 hp motor may carry the current of 20 ampere, and this much current and this much power is available in the lab. Whereas the motor is 100 hp or 50 hp, like that, the power will not be available, or it requires a large amount of power, and that power is going to wasted in the amount of heat and generated around the say uh, loading arrangement, mechanical loading arrangement. So the large motor cannot be tested by this method, and if it is possible, it requires a large amount of power as well as the large mechanical loading arrangement. The drawback of brake test is that is we cannot determine the error occurring in the spring balance, because it is unavoidable. Spring balance may not be a correct because of the long use, or it may be the aging effect. The spring balance does not give the correct loading arrangement, and that's why it is difficult to determine the correct value of losses and correct value of the, we can say that, the efficiency. In this case, the power or the more heat is going to wasted over the uh, belt as well as the pulley. Now, while performing the brake test on the DC series motor, it must be ensured that the belt on the pulley must be tight enough. Otherwise, the series motor without load or with light load condition may attain the dangerously high speed. Is this the difficulty only for the, especially for the DC series motor? Because DC series motor cannot be run for a small time even, or some higher longer time at no load condition. Otherwise, it will pick up the dangerously high speed. To avoid such a phenomena, it is necessary that we should put the load on the motor. And when we putting some of the load at the initial condition, it is difficult to determine the correct value of speed regulation. So these are the advantages and disadvantages of direct load test. So thank you for this lecture. Next time we will do some calculation under the direct load test method.